So what we're going to look at now is how to tell what type of regression is better for a set of data. And we're also going to start to look at how regression is more likely to be used, which is when we can't find a perfect equation, but we're trying to find an equation of best fit. So here I have some data, and we're actually going to find the regression equation of each of the 4 types, and then look at the scatter plot and see which line looks like it comes closest to those points. So you'll notice that we have more points than we need for this equation. It is possible that these points form a perfect straight line or a perfect exponential function or something like that, but they do not form a perfect type of anything, and we'll kind of see how each one fits. So first off, I'm actually going to look at the scatter plot so we can talk about it. So I have some directions for creating a scatter plot. Now, technically, for your understanding, this is something you should know how to do. It's not really something that's going to be assessed, but this is an important topic as we go into the next lesson where we have to do word problems with this. So what I do to get my scatter plot on is I press y equals, I move my cursor up to plot 1. I'm also going to clear out that equation. So I move my cursor up to plot 1, press enter. So when I see this dark, that means the scatter plot is on, and that's the default statistical plot. Then I press zoom, and number 9 is a statistic zoom, and it'll look at the numbers in my list and zoom into where they are. So I can already tell that this is kind of curved, so I'm guessing the linear is not going to be the best option. But, I mean, is it going to fit better with a quadratic, an exponential, or a power? I'm not really sure, so we're going to find each of those. So we will still find the linear one. So I'm going to go to Stat, Calc, LinReg, press enter through my menu, and that equation is 48.91x minus 111.82. Now, this is extra. This is something that's just for this problem so we can see it. I'm going to go back through that menu, noting that this is not necessary in general. So I'm going to go back to the linear regression, and I'm going to do something here called storing the regression equation. So it's going to take the full equation and store it in Y1. So to do this is the second part of the directions. So I went down to that. I'm going to press the bars button, which is right underneath the arrows, bars, go over to Y bars, choose function, and I'm going to put that equation in Y1. So now I should just see this other option. So nothing looks different, but if I go to y equals on my calculator, I see that unrounded, I have that equation typed in. So I'm going to go through and do the same thing with each of my other ones. So my next one I'm going to pick looks like it's quadratic, so I'm going to choose number 5. And this one, I'm going to store this equation in Y2. So bars, y bars, function, y2. And that's just like a copy paste over there. So here's the equation, we'll write it down. This is quadratic, so I have 5.07x squared minus 11.94x plus 11.59. Then we're going to go down to the exponential equation. And remember, I can always check, and I do see that, yes, that equation got pasted in Y2. So Stat, Calc, I can actually arrow up to get to it quicker because it's towards the bottom. Move down to my regression equation, bars, y bars, function. I'll put this one in Y3. So this equation is 3.19 times 1.67 to the x. And lastly, my power. So Stat, Calc, go up to A, and put this one in Y4. So my power function is y equals 2, rounds just to 2, times 2.30. Oh, that's wrong. I almost wrote an exponential equation. So we know our power function, and I can see that by the form they gave me, has to have the x as the base. And this is going to round to the 2.30. Now I have more exact answers in the y bars, right in my y menu, but that's basically what I can see. So we're going to graph it now, and if we look through carefully, blue, red, black, and pink. So these graph really fast on my calculator. If you're using one in class, it's a lot better. So blue is the linear, doesn't look so good. The red and the pink both kind of fall pretty much on the points to where it's hard to tell. The exponential one, and if I looked at it, I might have thought it was exponential, actually like bends too much. So I'm going to draw these out just so we have a clear example of this. So we don't need to really label anything. As I said, this is just to give us an idea of what's going on. So I sketch it out. The line is also blue, kind of doesn't touch those points super well. So this is linear. Both the quadratic and the power function, I'm going to say they both look almost the same. They're not exactly the same. If we zoomed in, we would see slight differences, and I can see a little bit of like spots where the pink and the red don't look exactly the same. And then my exponential kind of bends too far, like this, and that's exaggerated. But here we can kind of start to see that some of the equations might fit the points better than the other ones.